Hi, ladies. Welcome to Chapter 5, Day 2. We're going to continue talking about nomenclature. I have a couple of things to go through today and talking about your test. I'm hoping that this will be a little bit shorter than normal so that you guys have a little bit of time to still also work on your one-pagers for your Chapter 4 test. So we'll start with prayer and some updates. And prime time today, you're going to be assembling the naming compound spinner. So hopefully you noticed at the end of last class, I asked you to print that out. So if you didn't do that, you're going to probably want to pause the video at some point and get that printed out. Going over homework, doing some polyatomic ion stuff, how to use the spinner, and classwork and looking ahead. So prayer today is the Glory Be. So in the name of the Father, the Son, and the Holy Spirit, amen. Glory be to the Father, and to the Son, and to the Holy Ghost, as it was in the beginning, it is now, and ever shall be, world without end. Amen. In the name of the Father, the Son, and the Holy Spirit, amen. And don't forget, the prayer requests document is still out there for you guys to add to. Thank you for those of you who've been adding to that as we've been continuing along. And don't hesitate if you have special intentions and you just want to throw them out there as special intentions, please just do that. All right, so prime time today, you need your scissors and you're going to cut these two circles out. So you've got two circles that should be different sizes, and hopefully if you printed this out at home, they did print out different sizes and it'll work for you. So you've got the smaller one here that you're going to cut the circle out, and then you're going to cut this piece out also. So it's kind of like cutting out a quarter of the circle. It's a little less than a quarter, but this is what you're going to cut out. And then you're going to cut out the big one. If you have a brad that you can insert through these little center sections here, great. If not, you might be able to use a paper clip and bend it so that it's kind of like the brad. So this is what mine looks like, and I'm really sorry, but mine is in color because I normally copy these on colored paper. Sorry, that really wasn't going to happen this year. So this is what mine looks like. So go ahead and cut. I'm going to keep talking. You can listen while you're cutting at the same time. So we're going to be using this later on in class. This is working with naming of compounds, and I find that it's a useful tool, especially as you're getting going and trying to remember the different naming rules and things. So class update. Well, actually it said 7 classes left when I started this, and that's not true. We're down to 6 left. So the remaining classes, we're still going to be working on the rest of naming, and today we're doing polyatomic ion compound nomenclature, and next class we're going to be doing some stuff for filling in some notes for 6.1 and 6.2, which is material you've seen before. It'll be very short. They're really, other than filling in those notes as we're talking through class, there isn't going to be a whole lot unless I'm answering questions for you guys. I think that's it. Okay, Chapter 4 test. So I have already sent this out to you guys, and you've already seen the table with the information about your test. So your online quiz, I'm in the process of transferring my paper version of the test to the digital version, and so far what we've got is you've got matching for the history of atomic theory development, basically who did what, and you're going to be matching. Given a formula, counting the numbers of each types of atoms and total number of atoms. It's not going to be multiple choice, you're just going to enter a number. There's going to be some matching and multiple choice for things like where is a proton located, what's the charge of a neutron, what's the definition of an isotope, does a cation has a positive or a negative charge, things like that. Everyone will have one problem where you will need to calculate the average atomic mass. I will write in the problem statement how many sig figs to put in the answer. Some students will have 2 isotopes to use in their calculation. Some will have 3 because the program's just going to randomly select it. So you're going to want a little bit of scratch paper to be able to do this, and you're going to want your calculator. Sig figs are going to matter because it's going to be right or wrong when it actually is figuring out your grade. I will go back and take a look at things. But pay attention to your sig figs and round appropriately. Another section is going to be using period, group number, family name to determine what the element is. Like an example is which halogen is in the 4th period. So you're going to need your periodic table to look at and have your information about the period numbers as well as the group names, family names that we've got. And some questions similar to what you filled out in the table, and there'll be multiple choice or fill in the blank. I don't think it's going to be too long. I think you're going to find it pretty easy. Kind of looking at it as I go through, I think it's going to be easier than when we would normally do it on paper. So that's that. And if I have any additional information about it, I will send it to you in an email over the weekend. Okay, personal update. So I picked some pictures from when we visited the Philippines. I think I told you guys that when we lived in Singapore, we hired a lady to be our live-in maid, and she was from the Philippines. We ended up bringing her back here to the United States and kind of adopting her. We put her through Lakeland Community College, and she since has gotten married. Yeah. Sorry. And at one point, we ended up taking her and her husband and going and visiting her mom in the Philippines. And they lived in rural Philippines. But this is a picture over here of Manila traffic. And you can see it's like, I don't know, it's a zoo. The cars are close together. Rear view windows. I can't talk. Side mirrors on your cars, a lot of them are gone because the cars go so close together, and where there is room and markings on the ground for 5 lanes of cars, there could be like 9 lanes of cars. It's kind of crazy. This is kind of like a cab type of thing, but it goes to a very specific location. So people jump in here and they pay the driver. It's like a minibus. So there were lots of these, and people would jump on and jump off all over the place, like running through traffic. And they go out to a lot of the rural areas. So when we were out near where our friend lived, there's a lot of rice paddies. So they had the rice areas here. And on the roads, they take the rice and they dry it out on these tarps. So we would be driving out to her family's, where her family lived, down these gravel roads, and we had to keep pulling over to the side and going around because there was all this rice out on the road, which was kind of unusual to me. We did take a day and went sightseeing with some of her family members, and they took a bunch of food, which I think they must have been cooking for like a week in order to prepare all this food. But there are some traditional Filipino dishes here, as well as there's this huge container of rice, and they secured this to the top of our van by putting it inside a tire that they had bungeed to the top of the van. And it was covered with like saran wrap, and then they put a couple of like tarps over it. And we Americans were looking at it going, this is kind of odd. Because we would never have traveled with a bunch of rice sitting on the top of our vehicle. So, but we had this great food, great time, wonderful people. It was quite an experience to be out there. So some pictures from the Philippines. All right, I have a short video, and I think this is something that many of you might have already seen sometime in the past, because you may have had a cold bottle of liquid at some point, and it did this flash freezing. So here we go. So it's really cold, and you open the top, and then all of a sudden it just totally freezes, and it becomes kind of like slushy. So some of you may have had this happen to you, or had it happen to somebody you were with. I've left bottles of stuff in the car and come out and gone to pick it up and cracked it open, and then it just all froze. But you can see it's kind of slushy. So the reason this happens is because at standard temperatures and pressures, we know that pure water will freeze at 0°C. And that's only when it's at a pressure of 1 atmosphere. So when something is dissolved in it, the freezing point is going to change, and it typically is going to go lower. And that's why when we put salt on the roads, there are puddles of water, even though the temperature is below the freezing point. And the more salt, the lower the temperature must go before it freezes. But when you open a bottle, it does the opposite. Because there's carbon dioxide dissolved in any carbonated beverage, the freezing point's actually going to go from somewhere below 0, maybe -10 or so, to around 0 as soon as that carbon dioxide leaves the solution, and it happens instantaneously. And since the soda is already at like a negative temperature, it freezes as soon as the CO2 escapes. So that's also what happens with a can of Coke or a bottle of something that's carbonated. So that is what happens with the freezing point depression. So hopefully that's something that you guys have seen before. It's actually kind of cool. All right, chapter 5. Last time we talked about binary ionic compounds. Today we're going to talk about polyatomic ions. These are the hardest group of naming formula writing that we do. Okay, covalent is not really hard. Acids are not too bad. Balancing chemical equations takes a little bit of practice, but really of the stuff that we're doing, this is the hardest, I think. This is the stuff that I think the students find the most challenging, and this is the stuff that you need to spend the most time on. So I want to go over the questions from Blue page 30. Last time I did the first row, so let's talk about the second row. So number 5, when you find magnesium and fluorine on the periodic table, you should have labeled magnesium's column as having a +2 and fluorine's having a -1. So then when you crisscross the charges and put the numbers down as the subscripts, you get MgF2. And I did get a question in the survey about the negative numbers. And the reason you don't bring the negative down here to be a -1, because a -1 amount of something is not a real number. I don't know how you can have a negative number of atoms. So you're actually taking the absolute value of that number. So I think hopefully that answers your question. So you don't take the negative down, you just take the whole number. So then we've got magnesium and oxygen. Oxygen's in the column. That should have a -2 charge. When you crisscross them, both of them are going to have a 2, but since they're the same number, we're going to simplify, so you get MgO. Then we've got Mg and phosphorus. Phosphorus has a -3 charge. You crisscross them, you get Mg3P2. Then we've got hydrogen and oxygen. Hydrogen's in the first column, so it's +1, and oxygen is in the -2. So you crisscross them and you get H2O, and this is why water forms as H2O. Aluminum is in the +3 column, and oxygen's in the -2 column. Crisscross them, you get Al2O3. Aluminum and phosphorus, we've already done those charges. Crisscross them, they're both 3, but we can simplify, so they're going to be 1 for each of them. So then we don't actually write a number because a 1 is implied. Then Al and chlorine. Chlorine's a -1. So we've got AlCl3. The 1 for the aluminum is implied. Lithium and sulfur. Lithium is in the first column, so it's +1. Sulfur is over towards the right. It is -2. Crisscross them, we get Li2S. S would have a 1, but it's implied, so we don't need to write it. We did the 2 with iron last class. So then number 15 with copper, there was one oxidation state that had a +1. So when we crisscross that with oxygen, we get Cu2O. And then they give us another one with copper having a +2. And when you crisscross them, they both will end up with 2s, and you simplify and you get 1 for each of them, which you don't have to write. So you get CuO. So now you notice these two, we can't call them both copper oxide. We have to differentiate between the two, which is why when we're doing the naming, we have to identify the oxidation state in parentheses after the name of copper. So for 15, it would be copper, Roman numeral 1 in the parentheses, oxide. And for 16, it would be copper, Roman numeral 2, oxide. So that's page 30. Hopefully that will be, that answers any questions you had there. And then we had pages 10 and 11. Okay, so for the first one, lead 4 sulfide, Pb with a +4 charge, sulfur has a -2 charge, and yes, I realize sulfide is spelled with the British version of sulfur. Sorry, this worksheet came from, I think, a teacher in Australia, so they use the British spelling. So that is not how we would spell sulfide. Instead of the PH, we would spell it with an F. So anyways, when we crisscross the charges, we would get Pb2S4, but we can simplify that because both of them are divisible by 2, so we get PbS2. The next one, bismuth 5 chloride. Bismuth has a +5 charge, it tells us. Chlorine, we can look on our periodic table and see it has a -1 charge. Crisscross the charges, you get BiCl5. Okay, the next one, CaO, is calcium oxide. Calcium is not a transition metal, so we don't need to worry about its charges. CuS, well, we know that it's going to be copper sulfide, but if we look at where copper is on the periodic table, we'll see that it is a transition metal, and we don't necessarily know what the charge is. However, we do know the charge of the sulfur atom here. Sulfur is -2. And since we know that based on this, they have to be the same, we know that copper is going to be a +2. Okay, thinking about it, I think this one needs a little bit more explanation. So if we have CuS as the formula, sulfur is over here, so we know it has a -2 charge. So we know that sulfur has a -2 charge, but we don't know what copper is. But since we know that the formula we have for copper sulfide here is they both have a subscript of 1, we know that the sulfur has -2, so therefore the copper has to have a -2 charge, which makes this copper 2. Okay, so that's how we get that name. So then the other one where we have Cu2S, we have to work, kind of do the same thing. We know that when we know that sulfur has a -2 charge, copper, we don't know what its charge is. But we do know if we start with this Cu2S and we crisscross the charges here, or sorry, the subscripts, we would end up with something that was like +1, and sulfur would be -2. And we know that sulfur does have a -2 charge. So in this case, copper does have a +1 charge. So we end up with copper 1. Now I know this is not simple and straightforward, and it takes practice. I get that. I totally understand that, but that's why we're working on these now. Because next year you'll have these buried in problems that are much more complicated. And the practice that you get with this now is going to help you next year. I don't expect that you're going to be perfect at these. I don't expect that they're going to be easy right now. I do expect that with practice, and if you put in the practice, they will become easier and easier all the time. Okay, next ones. Iron 3 nitride. Iron's going to have a positive 3. Nitrogen has a negative 3. We crisscross them, we simplify, we get Fen. Titanium 4 phosphide. So titanium has a +4, phosphorus has a -3. Crisscross them, we get Ti3P4. Yttrium chloride has a +3, and chlorine has a -1. And when we crisscross them, we get YCl3. Then on page 11, tungsten bromide. Tungsten has a +5 charge. Bromine has a -1 charge. Crisscross them, we get WBr5. So taking another look at these, I don't think that the page that you guys ended up with in your blue packet that I scanned had these charges in parentheses. So I've gone back and added them in here. So if you were not able to figure those out because you didn't know the charge, that's probably the reason why. So I apologize for that. So I think I was at tungsten bromide. Tungsten has a charge of 5, not 4. So when you crisscross them, the 5 and the 1 come down, so you get WBr5. Then with scandium phosphide, that's another one that we have to take a look at and try to deduce what the charge of the transition metal is. So for SCP, we know that phosphide has a charge of -3, and since both of these are 1-to-1, they must have the same charge, which means that we know that scandium must have a +3 charge. So you're going to end up writing that as scandium parentheses 3 phosphide. The next one, vanadium 5 oxide, we've got V5 with +5, oxygen with a -2, crisscross them, we get V2O5. Niobium 5 sulfide. So again, we have to try to figure out the formula, or the name from the formula. So looking at the formula NB2S5, we crisscross, reverse them back up. So we put the 5 up here with the niobium. The sulfur would have -2, and indeed, when we look at our periodic table, it does have a -2 charge. So that way, we know that niobium is going to have a +5 charge. So it'll be niobium parentheses 5 sulfide. Iron 3 nitride. We've got iron 2, iron with a +2. Nitrogen has a -3. Crisscross them, Fe3N2. Nickel oxide. So this is another one that we have to take a look at what the charges are. So Ni, we don't know what the charge is for nickel because it has potentially a couple different charges, but we do know that oxygen has a -2 charge. And since when we look at the subscripts, they're going to be the same, we know that nickel has to have a +2 charge. So when we write out the name, we're going to write it out as nickel, parentheses, Roman numeral 2 oxide. Cesium fluoride, a nice easy one. We've got cesium is CS and it has a +1 charge. Fluorine is a -1 charge. Crisscross them, it becomes CSF. Then we've got molybdenum and chlorine here for MoCl6. So when we look at these MoCl6, when we reverse them to try to find out what the charges are, we've got Mo having a +6, chlorine having a -1, and when we look at the periodic table, chlorine does have a -1 charge. So that tells us that this is what molybdenum's charge is for here. So we have molybdenum parentheses Roman numeral 6 chloride. So I do know that these are challenging. I do know that these are hard. And we are going to keep working on them each time we have class to keep on practicing them. So what I want to go over today in the rest of the time that I have is talking about polyatomic ions. So I just want to warn you, there's a lot of very precise details coming, and you've got to be really careful and pay attention and go slowly with these next things, because that's just the way the rules for this work. So polyatomic ion naming rules. You have a worksheet in your that I had posted as one of your additional items, and it's got this chemical nomenclature at the top, and it does say it have polyatomic ions and their rules. And today I want to go over how we name all these things. We call them oxyanions, but they're the things that end in ate. So once you know and have memorized the polyatomic ion that ends in ate, which we had a whole set that we were working on memorizing. If you did that, you can take the one that has the 8, and if you add one oxygen atom to it and you don't change the charge, it becomes per that root 8. If you remove one oxygen atom from the 8, it now has the suffix "ite." If you remove 2 oxygen atoms, you're now going to have a prefix of hypo, and you're going to have the suffix of "ite." So let's do a couple of these so you can see what I'm talking about. So if we start with phosphate, and that is PO4 with a -3 charge, and you add 1 oxygen, you're going to end up with the name perphosphate. If you remove 1 oxygen, you're going to have phosphite. And if you remove 2 oxygens, you're going to have hypophosphite. So let's look at what happens with the formula. So we don't change the charge at all. When we add 1 oxygen, you end up going from O4 to O5. And so that's perphosphate. When you remove an oxygen from 4, you get 3. So that is phosphite. And when you remove another oxygen, you get PO2, and that is hypophosphite. So this is just the naming rules. This is something that you just have to learn. Fortunately, it's standard across all of these polyatomic ions that have an element with these oxygen atoms. So that does at least make it easy. They're not all random. So let's start with sulfur. So with the one with sulfur, we've got sulfate. So our starting point is SO4 with a -2 charge. So when we add an oxygen, it'll become persulfate, and it will be SO5, still having a -2 charge. If we start back with sulfate and remove 1 oxygen, we've got SO4 now. We're going to go to SO3. And if we remove another oxygen, we'll go to SO2, and that'll be hyposulfite. So what I want you to do for homework is I want you to pick 2 additional ones, not the ones that I just did, so not phosphate and sulfate. And I want you to just make 2 tables just like we just did. Choose any 2, make them with the per 8, the 8, the ite, and the hypoite. Pick any of the other ones and just make the table. I just want you to practice doing this so that you have it, and then you also have it as a reference. Okay, so that's the naming rules for those. In addition, on our polyatomic ion sheet that we started with before spring break, you had some that added hydrogens to those polyatomic ions. And when we added those hydrogens, there are some new naming conventions. So the most common ones are sulfate, carbonate, and phosphate. You add hydrogens to them, and you now have to modify the name and the formula. So the convention is when you start with sulfate and you add a hydrogen to the formula, you're just going to add the word hydrogen in front. So sulfate will become hydrogen sulfate. And the charge will change because you have to add a +1 to the existing charge. So you're going to have to do a little math, because hydrogen has a +1 charge. And when you add that to this existing charge, the ionic charge is going to change. So in this case, the charge is -2. And when we add +1 to it, hopefully you remember your math and you recognize that that's now going to be -1. So you add that hydrogen, and it's now going to have a -1 charge. Now, unfortunately, in addition to calling this hydrogen sulfate, there's a common name of bisulfate. And you will see this in some common places, and you will actually see bisulfite in some places also. Those are common things that you'll see in lots of stuff around when you look at ingredient labels and content labels. So let's look at carbonate. So carbonate, you start with CO3, which has a -2 charge. You add a hydrogen. It's going to be hydrogen carbonate. When you add that hydrogen here to the formula, you have to adjust your charge. So instead of -2, it becomes -1. So it becomes HCO3. And this has a common name of bicarbonate. You probably recognize the bicarbonate from sodium bicarbonate, which is baking soda. So this is something that's commonly found even around your house. So phosphate is the other example. So phosphate likes to add one hydrogen, but it can also add a second hydrogen. So for the first hydrogen, you're following the exact same rules. So it becomes hydrogen phosphate, HPO4. And since it's a -3 here, we add a +1. So it's now going to become a -2. And then when you add a second hydrogen, you change the word out front to become dihydrogen. So this is going to be dihydrogen phosphate. So this adds 2 hydrogen, and you didn't have to adjust the charge one more time. So it becomes H2PO4, and the -2 charge becomes a -1 charge. So these are naming conventions that we just have to learn. Fortunately, they're fairly logical. And I want to point out that these are on your polyatomic ion list. So when we go back and we look at the ones that I'd asked you to memorize, all the ones with the 8s, you will see that there are some ites and hypos, and you've got these hydrogen sulfate, hydrogen carbonate, hydrogen phosphate, dihydrogen phosphate. All of these are here. So since I also put all of the chlorine ones here on your chart here, do not do chlorine as one of your examples. So don't do chlorine, sulfur, or phosphorus. All right. So now we're going to use polyatomic ions and compounds, which starts on page 12 in your purple packet. We're going to do some fill-in, and then we'll be wrapping up. Okay, so the word polyatomic ion comes from poly, which means many, and atom. So we can conclude that a polyatomic ion is an ion made up of more than one atom that acts as a single particle. So there exist compounds created from polyatomic ions. For example, sodium phosphate is an additive in processed meats that help bind meat together. Sodium nitrite acts as a preservative in processed meats. So notice how these polyatomic ions do not end in the traditional IDE that we've already seen in binary ionic compounds. Remember, binary means that they only have 2 types of elements. So here we have an example of where we can see the phosphate and the nitrite in our, this was actually some sliced bread. All right, naming compounds involving polyatomic ions. Example, name the compound Cu2CO3. Step 1, write the name of the cation. This is usually the metal, but there are positively charged polyatomic ions. Does anybody happen to remember which one is positively charged that we had to memorize? So if the cation is a metal, check whether it has multiple ionic charges and include the correct one in brackets. So name the compound Cu2CO3. Copper is the cation. The copper has multiple ionic charges. So we have some possible ones. So we've got possibly Cu with a 1, which is CO with CO3. So that's one possibility. The other possibility was copper that has a positive 2 charge, and that would be our formula. So in this case, copper 1 is the cation that we're looking for. Step 2, add the name of the anion. This is usually the polyatomic ion. For polyatomic ion, there's no need to add anything to the end of the name. So CO3 with a negative 2 charge is called carbonate. So in this case, Cu2CO3 is called copper, parentheses, Roman numeral 1, carbonate. Let's do another example. CaOH2. Calcium's the cation. It only has 1 charge. Hydroxide is the anion. That's what OH is. So this is called calcium hydroxide. That's not too bad. SN parentheses NO3 close parentheses 4. So the cation has 2 possible charges, +4 and +2. NO3 has a negative 1 charge. So, and we know that from our polyatomic ion list. So this tells us that tin, in this case, must have a positive 4 charge. So it'll be tin 4. Nitrates are anion. So this is called tin, parentheses, Roman numeral 4, nitrate. Then we've got NH4NO2. So ammonium is the cation. That is our 1 positively charged polyatomic ion. NO2 is not nitrate. It is actually nitrite because it has 1 less oxygen. This compound is actually made up of 2 polyatomic ions. So this is called ammonium nitrite. So ladies, I don't expect that you're going to have all of these polyatomic ions memorized. Keep your charts handy. Keep the naming conventions handy so you have that with you. Okay, so let's try a few more. So this one, MgCO3. So Mg doesn't have multiple charges. So this is going to be magnesium something. CO3, if we go and we take a look at it, it is carbonate. So that is going to be magnesium carbonate. Okay, CuSO4. Copper has multiple charges. So what's the charge of SO4? Well, that happens to be sulfate, and that has a -2 charge. So they must be the same. So that means that copper 2 sulfate, and this, I should just fix this. This should be an F because this is not the British version of the spelling. Okay. So copper 2 sulfate. Then this next one, these has 2 polyatomic ions, NH4, which is ammonium, and OH is hydroxide. So this is ammonium hydroxide. Then we've got FeNO2 3. So we look at this FeNO2 3, and we crisscross, reverse crisscross to find out what the charges should be. Fe would be +3, NO2 would be -1, and nitrite does have a charge of -1. So we end up with the formula here for iron 3 nitrite. And then if we look at the next one, FeNO3 2, and we reverse crisscross, this will be Fe plus 2, and O3 would have a -1, which is true, and this is nitrate because it has 3 oxygen atoms there. So we end up with iron 2 nitrate. Notice we have a nitrite and a nitrate. And then the last one, NH4Cl. We've got NH4 is ammonium. Cl doesn't have multiple charges and it's not polyatomic. It is chlorine, so it becomes chloride. So we end up with ammonium chloride. So writing formulas involving polyatomic ions. So example, write the chemical formula of aluminum phosphate. So step 1, write the symbols of the ions and their ionic charges. The cation always goes first and anion is always last. So aluminum has a +3 charge. Phosphate is PO4 and has a -3 charge. When we crisscross them, we're going to bring them both down, and when we simplify them, they're both going to end up being a 1. So we end up with AlPO4. All right. So a warning here, really important. Highlight this, star this. So be careful. Ca2NO2 does not reduce to CaNO because here there's one nitrogen. Here there's 1 nitrogen. If you divide your calcium by 2, oxygens by 2, you'd have to divide your nitrogens by 2, and you cannot have a subscript of a half here. It's really, really common to make this mistake. Okay, so you've got to be careful as you're trying to simplify and reduce that you put parentheses around anything that would need multiple groups of that atom or that polyatomic atom. So this Ca2NO2 is already the lowest ratio because there's only 1 nitrite ion. Use brackets when using the crisscross method for polyatomic ions. So let's try these. We've got tin to phosphate. So when we take a look at it, tin has a +2 charge, phosphate has a -3 charge. So when we write them and crisscross them, we're going to get SN3 parentheses PO4, close the parentheses 2, because there's got to be 2 phosphates. Next one, calcium sulfate, and there's that British spelling again. So calcium has a +2 charge. Sulfur has a -2 charge. When we crisscross and simplify, they're both going to have 1, so it's CaSO4. So you don't need a parentheses around here because there's only 1. Copper 2 nitrate. Okay, copper 2 and nitrate. So for here, copper has a +2 charge. Nitrate has a -1. When we crisscross them, we're going to have copper with a 1 and the nitrate with a 2, so it needs a parentheses around the whole NO3. Copper 2 nitrite. Nitrite has a formula of NO2. It's got a charge of -1. When we crisscross these, we get the 2 comes down under nitrite, the 1 comes down under copper. So we've got Cu parentheses NO2 parentheses 2. All right, so pause the video and do page 15 before you go ahead and continue. Go ahead and work through a few of these. You've got some naming compounds and writing formulas. Last thing I want to talk about is doing page 16 and using your spinner and the periodic table. So we're going to do numbers 1 and 5 in the top part, and then we're going to do a couple in the bottom. So page number 1. So look at the questions that are written here on the spinner. So NABR. So question 1. Look at the chemical formula you're naming and ask yourself these 3 questions. Question 1, are there more than 2 elements? No, there's only 2 elements. So no means go to question 2. So question 2, is there a metal? So a metal means there has to be something over on the left side of the periodic table. So yes, that tells us we should go to question 3. Question 3, does the metal have multiple ionic charges? Well, no, it's sodium. It's in the first column, so it only has 1 charge. So that means it's a binary ionic compound. So then you're going to turn the top circle, and mine is yellow, so that you can see the part of the circle that says binary ionic compound. And it gives the information here about how to name it. It says write the name of the metal, then write the name of the nonmetal, and change the ending to "ide." So in this case, we write sodium, and instead of bromine, it becomes bromide. So you end up with the name sodium bromide. So another naming example is BeOH, parentheses 2. So we're going to look at the questions again on the spinner. Question 1, are there more than 2 elements? Yes. So it says go to compound with polyatomic ions. So now you're going to turn the top circle so that you can see the part that has compound with polyatomic ions underneath. And here's mine. So I've turned my spinner, and we've got the information here. It says write the name of the cation, usually the metal, add the Roman numeral in brackets if the metal has multiple ionic charges, then add the name of the polyatomic ion. So here we've got beryllium. It only has 1 charge. And then we've got hydroxide. So the name of our compound is beryllium hydroxide. So this is how we're going to be using this naming spinner. If this is helpful to you, use it. If it's not helpful to you, don't use it. We haven't covered molecular compounds yet, and we will be doing that next week. And that may have this come in more handy then. So then the bottom section, I want to go over the 7, 13, and 15. So we've got 7, which is magnesium oxide, 13 is magnesium hydroxide, so a polyatomic ion, and 15 is aluminum carbonate. So magnesium has a +2 charge, and oxygen has a -2 charge. So when we crisscross and simplify, we get MgO. So then looking at number 13, Mg has a +2 charge. Hydroxide has a -1 charge. So when we crisscross them, we get Mg would be 1 and OH would be 2. And we don't need the 1 there because it would simplify. Then 15, we have Al, which is aluminum, and carbonate, which is CO3, and it has a -2 charge. So when we crisscross, we get Al2 and CO3, 3. And we need the parentheses there. Otherwise, it would look like we had Al2, CO3, 3, which would be 33 of them, which is not correct. Okay, so ladies, I'm only wrapping up a little bit early, but at least I got through everything. And so these are the answers. So for homework, you've got turn-in work due Monday, May 11th at 8. The worksheets that we've been doing here in class, so go ahead and finish up writing down information for 12 through 16, as well as the 2 polyatomic ions that I was discussing earlier in the video. So don't do the 2 that I went through or the 1 that was on your polyatomic ion discussion sheet. And you've got your chapter 4 test. The 1-pagers are due at 8 a.m. before you start your online portion. I've heard from quite a few people who are taking the AP Gov test, and we're making other arrangements for them. But if I haven't heard from you, I'm going to be assuming that you're taking it at the normal time. The survey is up, and I really did enjoy looking at your favorite Disney movies. So thank you, ladies. And it also gave me some good feedback on what you were having some questions on. So be sure to fill out today's, because I had a couple more very specific questions about naming and formula writing. So bookwork. What we did today is, actually, it was not this. Okay, it was section 5.5 today. I skipped over 5.3 and 4 because I wanted to talk about polyatomic ions today because they're ionic compounds. So that's the section that we talked about today. And looking ahead, curation project, final one will be due May 19th, which will be just before we're getting out for the term. And that one, you're going to have 2 more resources. So I've gotten a lot of emails from you guys. I've got copies of the web links for your current curation project. I'm going to be working on grading those and finishing up your test. Ladies, if you have questions for me, send me an email, fill it out on the survey. So you're going to be doing this on the 7th. So ladies, have a good weekend. Good luck with all of your work, and I will be in touch.